So we're going to do 1022. 1022 is an extension of 1021. We're going to be adding and subtracting functions. This is my second swing at this one because I got a different answer than the book. I was a little bit confused by it. Honestly, I think I'm right and the book is wrong, although I guess I will throw this on the internet and you guys can check it and see what you think. If I ended up making the mistake, I just don't see what the book is saying, so it kind of threw me. And so I checked the video and I'm starting over, so a little bit frustrated, but hoping this won't be the longest video. So anyway, Steph is in charge of ordering team accessories for a soccer team. She wants to order custom socks that have the team's name on them from an on-site supplier. The socks are $10 each with $5.95 shipping. They want us to write F of X to represent the total cost of the socks for each person. That's just to sketch this. I'm actually going to do this in Desmos. So I'm going to do A through C and then go to Desmos. So F of X equals 10X plus 595. And then, like I said, when I'm done with C, we'll jump over to Desmos, then we'll come back and we'll talk about D and E. All right, so Steph finds some headbands that she would like to order. The headbands are $22 each plus $6.50 shipping and handling. So we're supposed to write G of X, and G of X is, of course, going to be 22X plus $6.50. And then we'll sketch that in Desmos. And then it says Steph decides that she would like to order both pair of socks and a headband for each person on the team. How could she combine F of X and G of X to represent the total cost? Well, obviously what we're going to do is we're going to add F of X plus G of X. And actually in Desmos or in the calculator, again, if you want to use the TI-84, you could just leave it as that, Y1 plus Y2. But just for the math, 10X plus 22X is 32X. 595 plus 650 is going to be 6 plus 650 is 1250 minus the 5 cents is 1245. So what I'll do is I'll jump over to Desmos. You'll see I already have these pre-slugged, the 10X plus 595, the 22X plus 650, etc. So if we go here, you can see here is my 10X plus 595. You can see there's my y-intercept and it's going up 10 over 1. That's for the socks. The headband has a slightly higher intercept and a much steeper slope. And then if I want to add these two together, you can see Desmos will just let me add F of X plus G of X. Again, if I wanted to, and you get that green line, a couple of points I want to make before I talk about the next thing is, you'll notice that y-intercept has a y-intercept of about 1245. That's going to be the 595 plus the 645. Also, it should have a slope of 32x. So I want to show you that that is indeed the case. So if I were to have done this and written it out like this, as opposed to have just written F of X plus G of X, you'll see that they perfectly line up. So the Desmos is taking F of X plus G of X as 32x plus 1245, so it does work that way in Desmos. It works that way in your TI-84 as well. The company from which Steph is ordering socks and headbands said that they will offer free shipping if the order is more than $400. Well, we could say F of X plus G of X needs to equal more than $400, or I think it'll be easier mathematically to do this, so I'll say 32x plus 1245 is greater than 400. If I subtract 1245, I'm going to get 32x is greater than probably 387.55, I think I'm going to get. So 387.55 it is. Now if I divide that by 32, I'm going to get x is greater than 12.11. Well, obviously, if we're talking about socks and headbands, it needs to be more than 12 of them. So, and I wouldn't order half of a headband or something. I guess you can order half of a pair of socks, but that'd be weird. So I think we're looking at 13 pairs as the answer. And again, I hope that makes sense because it needs to be more than 12, and that's the next whole number. So how would the graph y equals f of x plus g of x change if the shipping and handling is free? Well, what we can do is we can go over here and we can see that if shipping and handling was free, I would just subtract the $12.45, right? So you can see this is what it looks like. It just has a y-intercept of 0. So I could, in this one, just subtract $12.45 as well, and that would give me the exact same thing. So hopefully that makes sense. I keep going to that one. I do not want to go to that one. I want to go to this one. All right, so 1087, Lori has 2 accounts at her bank and wants to keep track of her total amount of money she has. One account is a special savings account that is called the CD, or certificate of deposit. She's deposited $20,000 in the account. It grows 2% interest compounded monthly. If you'll remember, I think this goes back to 814, maybe 815, where it's y equals a times b to the x, but it's a little bit special if we're compounding it monthly or quarterly or something like that. So S of t is going to equal a is our starting point, 20,000, times b is our multiplier, and normally we would say 1.02, but in this case we're not getting 2% interest once, we're getting 1/12 of 2% 12 times a year. So I'm actually going to take the 2%, I'm going to divide it by 12 because you're getting a chunk of that 2% each month, and then I'm going to go 12t because you're getting that 12 times a year, not once a year. So hopefully you remember that. If you don't, go watch those old videos like 814 or something like that. Actually, I haven't even made that video yet, but it will be an old video at some point. Anyway, Lori's second account is a checking account. She currently has $2,000 in this account and deposits $1,500 for work earnings each month. So W of t is linear. She's going to start with 12. She's going to add $1,500 a month, and she's going to start with $2,000. So there's S of t, there's W of t. Lori wants to keep track of the total amount she has in the bank. Show her how she can use the equations. Well, she can say S of t plus W of t, and that'll add those together. So let's go ahead and look at those before we come back and solve D. So if I look here, here's the first one. And you can see again, I divided that 0.02 by 12 and went to the 12th power. So it's not anywhere, it's not showing at all. That's because my y-intercept is so big. So if I zoom back till I get 20,000, I mean, you can see I kind of have a problem there because it looks like a big line. So we'll talk about that in a second. Let me show this one as well. And again, it just looks like 2 lines on top of each other. The issue is the y-scale is rather large, but the x scale isn't. So if you're looking at this, you might be a little bit confused. You can just go into Desmos, into graph settings. Again, the y is fine, but I'm going to change the x to go from 0 to, I don't know, maybe like 10. That should get us to zoom in a bit, and then we can go from there. So I'm at like hundreds of thousands, I can see. Yeah, maybe I do need to make the y scale. I'll make the y scale go from like I'm sorry, that's the x scale. I'll make the y scale go from like -50 to, let's say, like 100,000. And that's looking, actually, I guess we can make the y scale go to like 50,000 instead. That might be better. So just sort of playing with it to see what we can get. And it's going to look something like that. Now, what does it look like if I add them together? Well, first of all, I want you to see again, here's the equation where I wrote the whole thing out. It looks like this. I think there should be another 0 there. So it looks like this. But if I just say S of t plus W of t, I should get the same one. And I did not. So let's see here. 1500t plus 2000. S of t plus W of t. Huh. Oh wait, yeah, no, I do have the same one. That red one's throwing me. I'm so confused. Sorry for that dramatic pause. Let me get rid of these two. And you can see I did get the same equation. I was just so confused why I didn't get the same equation twice. It was very confusing to me. I apologize for that dramatic pause. I'm not editing that out. This is the second time doing this one already. I'm not going to do 3. So Lori has decided that when she has $35,000 saved, she will spend some time traveling. How long until she begins her travels? Well, there's a lot of different ways we can do this, but since I already have it in Desmos, I think the fastest way would be, let's see where she is at 35,000, right? So there she's at, just sort of clicking on it, she's at 32,000, 34,000. There she is, about 35,000, and you can see it's 6.7 months, 7 months, a little bit less than 7 months. The book has this down as 9 months, but I just get 7 months when I do this. So the first time I made this video, I was completely thrown, much like I was right there when I confused these two red lines. So same kind of a thing. I was completely thrown, but I feel like 7 months is the answer. So I'm going to go ahead and say about 7 months. Again, if you check this and realize I'm wrong, feel free to reach out to me and let me know. Alrighty, we will go ahead and go to 10.2.2 and finish this up. So around the world, Lori has saved some money for her trip around the world. She's now planning her travels. She predicts that plane tickets will cost $3,500. She'll spend $33,000 a month. So write an equation C of t for the amount of money Lori's spending. So a lot of kids get confused on this one, and they think that we need to be subtracting, and we will subtract later, but right now it's counting how much money you're gonna spend. So think about it like if you've ever been in a cab, the meter counts up, and then at the end, you subtract that amount from your wallet. So same idea right here. We're going to write an equation that adds these together. And then what we'll do is we'll subtract it from the other equations later. So anyways, it's going to spend $3,000 a month and $3,500 for the plane ticket. Again, that's a positive amount of money that we're going to spend. So when we spend the money, we'll subtract it. Lori has set up a special bank account to use while she's traveling. She deposited $5,000 to begin with, and will have $2,500 a month transfer from her savings account. So she's going to have $2,500 a month going in, and it's going to start with $5,000. So use your equations for part A and B to write the next equation, right? To describe what's happening. Well, she's going to start with T amount of money, and from there, she will subtract the C money. So if you think about it, she's going to have 2,500 T plus 5,000, and she's going to subtract from it 3,000 T plus 3,500. So I'll distribute that negative. I'll get 2,500 T plus 5,000 minus 3,000 T minus 3,500. I'll combine like terms. I get minus 500 T plus 1,500. So essentially she's going to start with $1,500, and then she's going to lose 500 of that a month. So obviously that's going to allow her to go 3 months of travel. But again, we can sort of jump over to Desmos and see here's how much money she's spending. And again, our scale is kind of messed up here. So again, we can go in and maybe try and fix this a little bit, and having our X scale go to like, I don't know, between like -5 and 5. And we'll have our Y scale go from like, I don't know, -10 to positive 5,000. So we get, that's how much money she's spending. That's how much money she starts with, and you can see they're going to cross. So one thing you can do is follow them until they cross, and you can see they cross at 3 months and $12,500. That's the total amount of the trip. Or we could do this, and we can subtract them from each other, and you'll see that she starts with $1,500 and ends up at 3 months with no money. So a couple different interesting things going on there with Desmos that I wanted to show you, even though it didn't ask for that. I did think it was kind of worth looking at. Alrighty. 1089, Lori's vacation is over and she's back at work. Her boss wants her to use her computer to keep track of the total amount of money the company has available. The company has 3 accounts. P of X is an investment account the company uses to earn interest and save money. So P of X puts money in their pocket. R of X is an account with money from payments received from customers. That also puts money in their account. E of X is their expenses. So we'll subtract out E of X. It doesn't matter what the equations are. Every year when we go over this in class, kids are like, well, I don't know what the equations are. It doesn't matter. This is ultimately what they're trying to show you, that you can add and subtract the functions. It's not a huge deal if you don't know what they are. Again, just saying something like T of T minus C of T is fine. You don't actually have to have the numbers. All right, I hope that makes sense. Again, as always, feel free to reach out. As always, you should be doing this work yourself. Sorry for my dramatic pause mid-video. Have a good one.